Okay, it's Sean Lum again, and today we're going to be reviewing some reaction mechanism stuff. So reaction mechanisms, again, are the actual sequence of steps that happen and occur during a reaction. So what we see here is a reaction mechanism that is occurring. In this reaction mechanism, there's 3 steps, and if we add everything up from these 3 reactions, or these 3 steps, we get what is called a total reaction. Now there's a few problems with the total reaction, is that some things can cancel out. We see that this N2O2 can cancel out with this N2O2, and this N2O can cancel out with this N2O. And what we're left with is what we call the net reaction, or what is left over. So right here, these are the actual net reaction, and we get a net reaction that is the kind of more typical reaction that we see. Now everything that is not in the net reaction is everything that is not in this net reaction is called a reaction intermediate. So as we talked about before, this is not in the net reaction, and this is not in the net reaction. That's why these things are reaction intermediates. Okay? They happen in the middle of the reaction. So as we see, N2O2 happens in the middle of the reaction, and same with N2O, it happens in the middle of the reaction, but it's not a reactant, and it's not a product. Okay, it's not a product at the very end, and it's also it's something that you don't start with. So you don't start with it, and you don't finish with it. We call it a reaction intermediate. It only is short-lived in the middle. Now, here is another example of a reaction mechanism. This reaction mechanism is a 2-step reaction mechanism. So we're going to do the net reaction here. So as we see here, we have NO2, and that can cancel out with this NO2. And we have NO, and that can cancel out with this NO. And so our net reaction is, well, we just take everything and add it up, and our net reaction is O3 plus oxygen makes 2O2. Okay? So everything is canceled out. Now, reaction intermediates. Again, a reaction intermediate is something we don't start with it and we don't finish with it. Okay? So, something that we don't start with is NO2. Okay? And we don't finish with it. So we don't start with NO2 and we don't finish with NO2. So NO2 is our reaction intermediate. Okay? Now, you may be wondering, well, NO2 is our reaction intermediate. What about NO? Do we start with NO? And the answer is yes, we do start with NO. Do we finish with NO? Yes, we do start with NO. We do finish with NO. So we start with NO and we finish with NO. It does cancel out. So this is called a catalyst. Now, NO is a catalyst, NO2 is a reaction intermediate. A catalyst is going to lower the activation energy to make this go faster. So another way that you can think of it is if you were to connect the 2 things that cancel out with a line, Okay, and we were to connect these two things that cancel out with a line. Anytime your line goes in this direction, this is called a reaction intermediate. Anytime your line goes in this direction, it is called a catalyst. Okay, so as we see here, NO and NO, they cancel out, but the line moves in this direction. So it goes from top left to bottom right, therefore it's a catalyst. And for a reaction intermediate, it goes from top right to bottom left in this direction. It's a reaction intermediate. Or the other way you can think of reaction intermediate is you don't start with reaction intermediates and you do not finish with reaction intermediates. However, catalysts, you do start with catalysts and you do finish with catalysts. So we see here, we start with NO and we also finish with NO. So it's a catalyst. Now, the rate determining step is just the slowest step. So let's get that into our notes. The rate determining step is the slowest step. Okay, and the slowest step is step 1. Okay, so we see step 1 is the slowest step. So step 1 is what we call the rate determining step. It is the step that is going to determine the rate of a reaction. Okay, so this is the step that it is the slowest step, and it is also the step that determines the rate of reaction.